Everyone is rushing to deploy agentic AI right now. I mean, it is the only thing venture capital wants to fund, and it's pretty much the only thing engineering VPs are being told to build. But if you look at the actual success rate of these deployments, agents that are supposed to autonomously write code or manage supply chains or handle customer service, the failure rate is just staggering.
Oh, absolutely staggering. We're seeing bots that get stuck in endless loops, bots that hallucinate these wild inaccuracies, or bots that just stop working entirely.
Right. And according to the deep dive we are doing today, which is based on a really comprehensive 2025 survey called Agentic AI, a comprehensive survey of architectures, applications, and future directions, the reason for this failure isn't that the models aren't good enough. The intelligence is there. The problem is this thing they call conceptual retrofitting.
Yeah, conceptual retrofitting, which is a very polite academic way of saying we're trying to jam a square peg into a round hole. We're taking these probabilistic, creative, and honestly slightly chaotic large language models, and we're trying to force them into architectural definitions that were written back in the 1980s for strict rule-based systems.
Right. It's like we're expecting a jazz musician to perfectly execute a forensic accounting spreadsheet. It just doesn't work. And the paper argues that to actually fix this, to move from just chat to actual action, we have to look at this through a dual paradigm framework. We aren't looking at one timeline of AI here. We are dealing with two completely distinct lineages, the symbolic and the neural.
And they effectively speak different languages.
Yeah.
If you don't understand the difference between an agent built on logic and an agent built on probability, you are going to build a system that either crashes the moment it sees something new, or worse, confidently lies to you when the stakes are at their highest.
So let's get into the mechanics of that, because the word agent is getting thrown around right now to describe everything from, a basic spell checker to an autonomous drone. But the source material draws a really hard line. An agent isn't just a tool you use.
Correct. A tool is passive. Like a hammer doesn't want to hit a nail. You want to hit the nail.
Right.
An agent, on the other hand, has a state it actually wants to achieve. It has a goal. It has autonomy. It has a desire, to use the technical term from the BDI model, that's belief, desire, intention.
The project proposal analogy from the survey really nails this shift from a tool to a system. If you go to a standard LLM, just a single agent, and you ask it to write a project proposal, it's a very linear process. It researches, writes, and formats it all alone.
Yeah, just predicts the next token until it's done. And if it gets stuck or doesn't have the data, it just hallucinates to fill the gap because its only goal is to complete the text.
But contrast that with an agentic AI, a multi-agent system.
Yeah.
You give it the exact same command. But the system doesn't start writing. It creates a team. It spins up a manager agent.
This is the orchestration layer. The manager parses your intent and realizes, hey, I can't do this alone. So it effectively drafts an org chart on the fly. It spins up a researcher agent to go browse the web. It spins up a writer agent to draft the text. It might even spin up a QA agent specifically designed to just tear apart the writer's work.
So agentic AI isn't about a smart bot, it's about orchestration. But here is where that conceptual retrofitting problem really hits us. How those agents talk to each other and how the manager decides who does what depends entirely on which lineage you are using. Are you building on the symbolic lineage or the neural lineage?
And that right there is the crux of the entire engineering challenge we're facing right now.
Let's tore those apart then. Starting with lineage 1, the symbolic. This is good old-fashioned AI. The paper references the 1950s through the 1980s as its era, but let's be totally clear for everyone listening, this still runs the world today. This is the autopilot on a commercial plane. This is the routing algorithm for a FedEx truck.
Right. And the defining characteristic of the symbolic lineage is algorithmic planning. It relies on explicit logic, rules, and if-then statements. It is entirely deterministic. Think of it like a strict contract.
The paper mentions Markov Decision Processes, or MDPs.
Yes, MDPs are a great example. In an MDP, you have a mapped terrain, you have a defined set of states, places the agent can be, and a defined set of actions it can take. The agent looks at the map, calculates the reward function for each path, and picks the optimal one. It's essentially a flowchart on steroids.
The strength there is obvious, right? It's auditability. If the agent makes a move, you can look at the math and say exactly why it did it. It moved left because that path had a 0.05% higher probability of success based on the coded rules.
Exactly. But the weakness is what we call state space explosion. If the agent encounters a state that wasn't on the map, say a drone flying via an MDP, encounters a weird type of balloon it's never seen before, and that balloon isn't in its obstacle database, the system fails.
It freezes.
It completely freezes. It's brittle. It doesn't improvise.
Because it can't hallucinate a solution. The math simply does not allow for creativity. There's no next token prediction. There is only if X, then Y.
Which brings us to the second lineage, the neural lineage, the generative era, basically 2022 to the present. We aren't doing algorithmic planning here anymore. The paper calls this stochastic orchestration.
Right, so we've moved from a rigid map to a probability distribution. A neural agent, powered by an LLM, operates in a high-dimensional vector space. It doesn't have a rigid rulebook. It has this massive, compressed understanding of how concepts relate to one another.
So when it encounters that weird balloon it's never seen, it doesn't freeze. It looks at the concept of flying object, looks at the concept of collision, and predicts that dodging is the statistically probable best move based on context.
It generalizes.
Exactly, it generalizes. That is the superpower. It can handle unstructured, messy, chaotic inputs that would break a symbolic system in a millisecond.
But the trade-off is the black box. We traded the map for a vibe. We traded certainty for capability. Since it's probabilistic, you can ask it the exact same question twice and get two different answers.
And in an engineering context, that is terrifying. If I am building a stock trading agent, I do not want it to execute a trade just because it felt like the right move based on a probabilistic roll of the dice.
This tension becomes super visible when we look at how these multi-agent teams actually coordinate. The paper dives into protocols, and this is fascinating. How do these agents talk to each other to get a job done? On the symbolic side, they use algorithmic protocols, like the contract net protocol.
The contract net protocol is a beautiful piece of computer science history. It models the agents as an economic market. It's basically a formal auction.
Right.
The manager broadcasts a task announcement. It says, I need 500 lines of Python code analyzed. The available worker agents look at their own CPU availability and their specialized capabilities, and they send back a bid.
Like, I can do this in 200 milliseconds with 99% accuracy.
Exactly. And the manager collects all those bids, ranks them, and awards the contract to the best agent. It is rigid, it is formal, but it is hyper-efficient and verifiable. You know exactly why Agent A got the job over Agent B.
Now compare that to the neural approach, which uses emergent conversation. We see this in modern frameworks like AutoGen or Crew AI. There is no bidding, there is no contract, it's just a group chat.
It's literally natural language negotiation. The manager agent sends a chat message that says, hey, can anyone handle this code? And a worker agent replies in English, yeah, I can take a look, but I might need help with the database part.
Which sounds incredibly human. But it introduces a massive risk that the symbolic folks never had to deal with: information cascades.
Or the echo chamber effect. In a symbolic contract net, agents are exchanging data fields. In a neural chat, they are exchanging rhetoric. So if the manager hallucinates, say, gives a wrong instruction or a false premise, the worker agents, who are literally mathematically conditioned to be helpful, might just agree with the hallucination. They amplify the error.
We've actually seen this exact thing in coding agents. The manager says, fix the mug in the login API. But the bug is actually in the database. The coder agent, instead of checking the database, just starts rewriting the API because, well, that's what the boss asked for.
That is the danger of stochastic orchestration. You lose the rigid checks and balances, you get goal drift. The agents get so caught up in the conversational back and forth that they literally forget the original objective.
So if we have these two lineages, the rigid, reliable symbolic, and the flexible but flaky neural book, the trillion-dollar question is, which one is better? And the application section of the paper makes it clear that it's not about which is better. It depends entirely on the stakes.
You have to match the paradigm to the penalty of failure. Look at healthcare. The paper cites Meditex AI.
Electronic health records, the absolute highest stakes.
Exactly. You cannot have a creative doctor. You need auditability and safety. So symbolic dominates here. You need deterministic pipelines.
But they still use neural, right? Just
Yeah.
constrained.
Yes. If neural is used, say, for transcribing doctor's notes or summarizing medical reports, it is heavily, heavily constrained by symbolic rules. It's an interface layer, not the decision engine.
It's like a wrapper. The neural network is the soft glove, but the symbolic logic is the iron hand inside.
Precisely. Now contrast that with finance. The survey looks at MasterCard's Decision Intelligence Pro. Here, the problem is completely different. It's not just about strict rules, it's about pattern recognition across massive amounts of messy data to spot fraud.
Right, because a rule-based system in fraud detection is always fighting yesterday's war. It only knows the fraud patterns from yesterday.
Exactly. If a scammer invents a new technique today, the symbolic agent misses it completely because it's not in its state space. So MasterCard uses neural agents for analysis. They use role-based workflows, where different agents look for different types of emerging risks. The generative capability lets them imagine what a new fraud pattern might look like.
But that brings us to the hardest category, robotics, the hybrid zone. The paper talks about Amazon Prime air drones and Siemens smart factories. You have high-level adaptability needs, but you also have physics.
Right, you can't hallucinate gravity. A neural network is amazing at computer vision. It can say, that is a tree or that is the delivery van. But you do not want a neural network calculating the exact rotor speed required to keep the drone stable in a crosswind. That needs to be pure control theory, symbolic math.
So how do they actually integrate them?
They partition the brain. The cortex is neural. It does the high-level planning, go to the house with the blue roof. But the brainstem is symbolic. It handles the motor functions and the safety constraints.
So the neural agent says go forward, but the symbolic agent can override it and say, veto, there is a wall.
The symbolic layer acts as a permanent guardrail. It's currently the only way to solve the safety problem in physical spaces.
Which naturally leads us to the governance gap. We're so used to worrying about bias or hate speech in AI. But when you give an AI agency the actual power to act the risk profile, changes entirely.
You can't regulate these two lineages the same way. The paper outlines paradigm-specific risks. For symbolic systems, the big risk is perverse instantiation.
The genie in the bottle problem.
Exactly. The AI follows the rules too literally and causes harm. If you tell a symbolic supply chain agent to minimize costs at all costs, it might just decide the best way to do that is to stop shipping products entirely. Zero shipping equals zero cost.
It maximized the variable you gave it, but it destroyed the business.
Because it lacks common sense. But neural agents, they have plenty of context. Their risk is hallucination, prompt injection, and goal drift. And that leads to the accountability crisis.
Attribution gap.
Yes. In a symbolic system, if the agent stops shipping, we can trace the code. We can find the exact line that says if cost is greater than X, stop. We know who messed up. But in a neural system, because the behavior is stochastic, it's probabilistic there's no specific line of code to blame.
The decision just emerged from billions of weights and biases. So who's liable? Is it the developer, the prompter, the model itself?
It is a massive legal gray area. And it means we can't just evaluate these systems on accuracy anymore. We have to measure their agency. Can they handle long, complex tasks without forgetting the goal? Benchmarks like Agent Bench are trying to test this, but it is incredibly difficult.
So to synthesize all of this, we are moving from a world of rigid rules, the symbolic, to a world of creative conversations in the neural.
And the future, the next frontier the paper points to, is hybrid intelligence. Neurosymbolic systems, integrating the absolute reliability of symbolic logic with the adaptability of neural networks. And critically, moving from stateless agents that forget you the second you close the tab to agents with lifelong learning and persistent memory.
I want to leave everyone listening with one final kind of provocative thought from all of this. We are rapidly moving toward a concept called delegated agency. We are shifting from AI that merely assists us to AI that acts for us.
We are essentially granting power of attorney to software.
Right. And if an autonomous agent signs a contract on your behalf or breaks a financial regulation and no human ever clicked approve, does our current legal system even have a definition for that?
It really doesn't. We are building the engine while driving the car.
So as you look at deploying these systems, look for the hybrid future. Don't use a hammer when you need a team, but definitely don't let the team operate without guardrails. Thanks for joining us on this deep dive.
It was a pleasure.
See you next time.